Hello everybody, my name is Daniela Álvarez Heredia.
Hello everybody, my name is Eduardo Ramos Berrondo. And together we are going to explain you uniform horizontal acceleration. This is our first problem and it reads as following. A golfer strikes a hole 3 seconds after hitting the ball. If the ball traveled at an average speed of 0.8 meters per second, how far away was the hole? So, okay, the problem tells us about this golfer who hits a ball. And he strikes the tee hole, or whatever it's called, after 3 seconds at an average speed of 0.8 meters per second. How far away was the hole? And now, when dealing with these sort of problems, we got to pay attention to the kind of speed they are giving us. Here, they are telling us about an average speed. Now we have this very important part that tells us it's an average speed, so we're gonna use the average speed formula, which is velocity equals distance divided by time, which would be velocity equals distance, the time that was 3 seconds, and well, the velocity is 0.8 meters per second, distance over width. So this is dividing. We're gonna pass this number multiplying. It's gonna be 3 times 0.8. Well, the seconds cancel with each other. We have seconds on top, seconds on bottom. And we're gonna have a total distance of 2.4 meters. That's our final result. The next problem reads as following. A train slows down from 60 to 20 kilometers per hour in a time of 8 seconds. Find the acceleration in SY units. So these problems are a little bit more complex because they aren't asking us for an average acceleration, but rather the exact acceleration in this precise moment. So we are gonna use one of these formulas, or two sometimes, depending on the situation. But well, we have the initial velocity is 60 kilometers over an hour, and the final velocity is 20 kilometers an hour. So I already see a problem here because these are kilometers per hour and we want SI units, international system. So we need meters over second. So let's make the conversion. 60 kilometers over an hour. 1 kilometer equals 1,000 meters. 1 hour equals 3,600 seconds. Yes, 3,600 seconds. So we make the conversion. Kilometers over kilometers eliminates. Hour with hour, and we get only meters and seconds. So it'll be 60 times 1,000 divided by 3,600. And we get 16.66 meters over second. This is our initial velocity. Now this one, also very easy to convert. Kilometers over an hour. 1 kilometer is equal to 1,000 meters. 1 hour is equal to 3,600 seconds. Kilometer by kilometer, hour with hour. well, 20 times 8,000 divided by 3,600. We get final velocity is equal to 5.55 meters over second. Yeah. So let me erase this in order to make more space for the problem. Now we have SY units, and then tell me find the acceleration with the specified data. I see the formulas, and well, I got final velocity, initial velocity, and time, so I can use this formula. So it will be final velocity, which is 5.55 meters over second is equal to initial velocity of 16 times 66 meters per second plus acceleration times time of 8 seconds. So I'm gonna take this subtracting because here it's adding up. 5.55 minus meters over second minus 16.66 meters over second. It's equal to acceleration times 8 seconds. Oh yeah, acceleration times 8 seconds. So I subtract minus 16.66. I get minus 11.11 meters over second is equal to acceleration times 8 seconds. So what do I do? This is multiplying, I pass it dividing, and it will be 8. And we do the rule of the tortilla, seconds times seconds, seconds squared, so the acceleration will be minus 1.38 meters over second squared. Why is it negative? Because the train is slowing down, and this is the final result.
Okay, and the next problem reads as following. A car maintains a constant acceleration of 8 meters per second squared. If its initial velocity was 20 meters per square north, what will be its speed after 6 seconds? Okay, here we have the acceleration of 8 meters per second squared. Then the initial velocity of 20 meters per second, and the time of 6 seconds. And we need the final velocity. So we're going to use this formula, that is initial velocity plus acceleration times time. And it will be 20 meters per second plus acceleration 8 meters per second squared times time, 6 seconds. And here we eliminate seconds. It will be 6 times 8 plus 20. And we have 68 meters per second. And the final velocity will be 68 meters per second.